We're going to interpret the sensitivity analysis for our previously solved problem. Okay. There's lots of pieces for this. We'll do them one at a time. So first of all, down here is talking about the constraints. Constraint 1, 2, and 3. Okay. First thing to look at is the final value versus constraint right-hand side. Constraint right-hand side is the constant right-hand side that you entered in. The final value is what the left-hand side equals once you plug in your variables. So in this case, if you compare them, you see that you used all of resource 1 and all of resource 3, so those were the binding constraints, but you only used 5 out of an available 50 of resource 2. When you subtract those, that means you had a surplus of 45 units of resource 2 that you could have used before having to resolve the problem. Now, what else do we have? This is the shadow price for each of the constraints. It tells you how much your objective function value, which in this case was 200, will go up or down for every unit increase in the constraint right-hand side. So a shadow price of this, 13.33, says if I can change my constraint right-hand side from 5 to 6, I'll get $13.33 extra in my objective function value. If I change it from 5 to 4, it would go down by that much. Now you can't change it as much as you want. That's what these allowable increase and decrease are. So for constraint 1, there's no decrease allowed, but 15 increase. So my constraint can go anywhere from 5 to 20 and have this shadow price still be effective. Okay. This 1e plus 30, by the way, is Excel's way of basically saying infinity. So this shadow price of 0 is from a decrease of 45 to infinity, so a right-hand side of 5 to infinity. Okay. Now up here, reduced costs are actually shadow prices for the non-negativity constraint. So this non-zero reduced cost here says that if you increase the non-negativity constraint right-hand side from 0 to 1, in other words, if you force x1 to be greater than or equal to 1, your objective function value will decrease by $28.33. Okay. Now, we have allowable increase and decrease on the objective function coefficients, and this tells you how much you're allowed to change your objective function coefficients without changing the optimal solution, which in this case is 0, 5, 0. Okay. So for instance, for constraint 2, we can decrease by 20 and increase by 40. Since it was 40 originally, anywhere between 20 and 80 will keep this solution of 0, 5, 0.